The Ghost Fleet of the Great Lakes, a deep dive historical narrative. The geometry of necessity. In the cold, unforgetting vastness of Lake Superior, a ship is more than a vessel. It is a moving factory. Since the 1890s, the Great Lakes have been the uncontested spine of American industry. The 1,600-mile freshwater highway that converted Minnesota iron ore and Pennsylvania coal into the steel sinew of a rising global power. The ships that ply this route, the colossal Lakers, were evolutionary triumphs, long, flat-bottomed, and designed solely to swallow and disgorge the raw material of wealth. When World War II exploded across the globe, the U.S. government faced an impossible mathematical problem: how to rapidly project naval power across two vast oceans when the coastline shipyards were already choked with construction. The answer, unprecedented and audacious, lay 1,000 miles inland in the placid, fresh waters of the American heartland. The Great Lakes, a region accustomed to building cargo haulers, was commanded to build warships. Not just any warships, but specialized, ocean-going landing ship tanks, LSTs, destroyer escorts, and corvettes. Vessels designed to fight Hitler in the Atlantic and storm Japanese islands in the Pacific. This created a profound logistical paradox. A shipyard in Milwaukee or Bay City could build a ship capable of crossing an ocean, but that ship, once completed, was too wide, too deep, and too tall to escape the Great Lakes. This historical truth is the key to the Ghost Fleet. The challenge wasn't naval strategy, it was geometry. The Chicago Funnel, the tight, shallow passage down the Chicago Sanitary and Ship Canal, the Des Plaines River, and finally the Mississippi, was the only route to the sea. The largest ocean-capable ships built in the lakes had to be stripped, dismantled, and in some cases partially submerged to squeeze through these riverine bottlenecks. It was a secret operation, a triumph of engineering known only to a few, and it created a supply chain for victory that remains one of the greatest and least known feats of American wartime logistics. The Ghost Fleet is the final, haunting result of this engineering audacity. Once the war was won, the fleet was sent back, up the Mississippi, through the funnel, and into the freshwater sanctuaries. They were not scrapped immediately. They were preserved, oiled, and kept battle-ready in a freshwater crypt, awaiting a new Cold War. This is the story of that colossal gamble. Part 1. The Impossible Cradle. Chapter 1. The Whales of the Lakes and the Steel Barons. The industrial geography of America is defined by its ability to move bulk. By the dawn of the 20th century, the Great Lakes were less a recreational waterway and more a meticulously engineered logistical artery. The steel mills of Pittsburgh, Gary, and Cleveland devoured iron ore at an insatiable pace. This ore was harvested in the Mesabi Range of Minnesota and the Upper Peninsula of Michigan, and the job of moving it fell to the Lakers, the largest freshwater freighters in the world, often stretching over 600 feet, specifically optimized for rapid loading and unloading by massive deck hatches. The early fleet was an extension of the fortunes of men like Andrew Carnegie and later J.P. Morgan's United Steel Corporation. These men understood that control of transport was control of the market. The shipyards of the lakes, Manitowoc Shipbuilding Company, American Shipbuilding Company, Great Lakes Engineering Works, were specialized machines, turning out these whales on an assembly line basis. Their expertise was in robust, high-volume bulk carriers, not fragile, highly engineered naval destroyers.
The water itself played a critical role in the rise of this power. Unlike salt water, the Great Lakes' fresh water provided a natural, low-corrosion environment, leading to a longer service life for the steel hulls. This single critical characteristic, the freshwater cradle, would later be the defining reason why the U.S. Navy and Maritime Commission chose this region to mothball hundreds of ships. It was nature's perfect preservation environment. When U-boat menace began choking Allied shipping in the North Atlantic in 1941, President Franklin Roosevelt realized that America needed not just more ships, but more kinds of ships, built faster than anyone thought possible. The Midwestern shipyards, with their deep reservoirs of skilled steelworkers, welders, and engineers, presented a geographically advantageous, untapped capacity. The challenge shifted overnight. Could the builders of the largest cargo ships in the world pivot to building highly technical, compact warships? The answer was a grudging, determined, and deeply complicated yes. Chapter 2. The Geometry of War. Building the Unbuildable. The directive was simple. Build LSTs. LST was the amphibious workhorse of World War II, a flat-bottomed behemoth designed to run right up onto a beach and offload tanks, trucks, and troops. They were 328 feet long, required a shallow draft, but critically had a 50-foot beam width. This 50-foot beam was the first and most significant conflict with geography. The main canal lock systems connecting the Great Lakes to the Atlantic, namely the old St. Lawrence locks, had maximum operational widths of just 44 to 45 feet. The naval architects in Milwaukee and Bay City became continental contortionists. They devised brilliant, complex solutions. The partially finished launch. Ships were launched not fully completed, but naked. Superstructures, masts, stacks, and even gun turrets were left off. This reduced the weight and height, helping to navigate low-clearance bridges and minimize the draft. The false side shell. For ships wider than the locks, an even more audacious plan was hatched for certain destroyer escorts. These ships were too wide for the old St. Lawrence locks, even stripped down. The solution? They were built in two longitudinal sections, bolted together, or launched with temporary blister tanks on the sides that could be filled or emptied to slightly change the ship's profile or list it to one side for clearance. However, the primary escape route for the vast majority of LSTs and smaller naval craft lay not east, but south, the infamous Chicago Funnel. It was a 300-mile, treacherous path of man-made channels and winding natural rivers. The route consisted of the Great Lakes, example Lake Michigan, the Chicago Sanitary and Ship Canal, the Des Plaines River, the Illinois River, and the Mississippi River, and finally the Gulf of Mexico. This route was a gauntlet of low bridges, some with only 17 feet of clearance, narrow bends, and fluctuating water levels. Captains had to navigate these massive vessels with mere inches of clearance, a tightrope walk of engineering and seamanship that demanded absolute precision. They would often have to ballast the ships down, fill their tanks with water, to pass under bridges, and then pump the water out again to lift them over submerged sandbars and shoals. The funnel was the secret beating heart of the inland war effort, a testament to the fact that the biggest obstacle to victory was often not the enemy, but the very map of the United States itself.
Chapter 3. The Landlocked Sailors. Navigating the Funnel. The ships were built by Midwesterners, but they had to be sailed to the sea. This required a unique breed of crew, the landlocked sailors. These men were often recruited directly from the lake's freight crews or from the skilled labor pools of the industrial towns. They knew the Great Lakes and its unpredictable fury,
its sudden gales, its dense, blinding fogs, and its crushing winter ice. But the rivers? The river journey was a completely different science. The task of piloting a brand new LST down the narrow, civilianized rivers required a combination of river knowledge and deep-draft naval handling that few possessed. The trip was a continuous, white-knuckled test of nerves and skill. A typical voyage through the funnel. Departure. The ships were stripped of their naval finery, looked strangely vulnerable. They were often referred to as ugly ducks by the shipyard workers. The canal squeeze. Navigating the Chicago Sanitary and Ship Canal, with its rock-cut walls, demanded that the ship's temporary wooden fenders scrape along the concrete, a continuous groaning sound of metal on stone. Bridge clearances. Every bridge required a mathematical calculation. River pilots would meticulously check water levels against tide charts and call ahead to have movable bridges manually opened. Sometimes, the only way to clear a low span was to wait hours for the precise moment when the water level dipped slightly, or to deliberately list the ship by pumping ballast water to one side. The Mississippi Run. Once they hit the main river, the danger shifted from clearance to currents and traffic. They were now in a major commercial waterway, dodging barges, towboats, and civilian vessels, all while piloting an untested, war-bound vessel. The landlocked sailors were the unsung heroes of this logistical chain. They delivered the ships intact to the saltwater ports, New Orleans, Baltimore, New York, where they were finally fitted with their remaining gear, weapons, and radar, transforming them from ugly ducks into battle-ready instruments of war. Without the bravery and ingenuity of these crews, the crucial LST fleet, vital for D-Day and the Pacific Island-hopping campaign, would have never reached the battlefields. The war proved the concept. The Great Lakes had become the most productive yet geographically challenging naval production center in the world, and soon the tide would turn and the mighty ships would begin their long, strange journey home.